Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about GCD and LCM. First, we can see greatest common divisor. Let us assume a two number. Just take 12 and 18. So, what is mean by GCD? Let us think. What are the divisor of 12 and 18? First of all, I can say it is 1. And then I can say 2. 2 can divide both. And 3 also can divide both the number. And then any other 6. 6 can divide both 12 and 18. Any other? No. There is no any other common divisor, right? Now, by seeing this, what is the greatest common divisor here? It is 6. So, my output will be 6. Fine. Okay. Let us take another example. Let us take 6 and 12. What are the divisor for this both 6 and then 12? What are the common divisors? I say 1, then 2, then 3, then any other? No, 6. Right? So, my output will be what? 6. Fine. Because 6 can divide the 6 and also this 12. Fine. So, this is my question. Now, how to approach this question? I can say I will iterate to the minimum value of this 2. I can iterate till the minimum value of this 2 and then check whether it is a divisor for both the number that is take for example this first example. Take this first example. First I will iterate from 1 to 12 to check whether any number inside this divides both this 12 and 18. If it divides both the number, I can say I will update my result. Fine. Let us see the code. See here. Div is equal to 1. Result is equal to 1. N1, N2 is equal to 45 and 54. I have taken two numbers, 45 and 54. Okay. While div is less than N1 and also div is less than N2, which means we are going to iterate up to the minimum number of N1 and N2. In this scenario, I will iterate up to 45, right? I will iterate to 45. Just put equal to because we will go up to what? That's 45, right? Now, if n1 mod div is equal to 0 and n2 mod div is equal to 0, then I will update my result. I will update my result because that divisor is common for that n1 and n2. So, I will update my result. Then I will just increase the div, right? Again, print result. Just I am submitting it. The answer is 9. Now, let me put 12 and 6. Let us see. The answer is 6, right? So, this is the first method. And then, second method is Euclidean approach. Euclidean method, right? What is mean by this Euclidean method? Let us take this Euclidean method works on a basis of a formula like n1 should be assigned with n2 and then n2 should be assigned with n1 mod n2. Fine, fine. So this is the working of this Euclidean method. First we want to do this, then we want to do this. Fine. So let us take for example. First of all, take two numbers. What are the two numbers? See here, 12 and 18. Let us take 12 and 18. 12 and 18. Let us take n1 as 12 and n2 as 18. Now, by doing this step, I can say n1 is assigned with n2. Just assign 18, comma, n2 is assigned with n1 mod n2. What is n1? It is 12. 12 mod 18. 12 mod 18, which is equal to what? 18, comma 12. This is my first iteration. Again, what is my second iteration? It is just assign this 12 to n1. I have assigned. Now, 18 mod 12, which is equal to 12, comma, what? 6. Fine. Again, do the same procedure. 6, comma, 12 mod 6, which is equal to 6, comma 0. Now listen carefully. Stop here, because we have got the result as what? 0. We have got the result as what? 0. So take this as an answer. So 6 is my answer. So this is the equilibrium method. When this n2 becomes 0, my n1 is my answer. So my output is what? 6. Fine. Okay. Again, let me take another example and try to solve that, so you can feel much better for this approach. See here, let us take 8 and 10. Let us take RLs 8 and 12. Okay, first of all, when we are doing operation like n1 is equal to n2, so it will become like what? 12 comma 8 mod 12, which is equal to 12 comma 8. So this is my first step. Then again do this. 8 comma 12 mod 8, which is equal to 8 comma 4. Right? Again do 4 comma 8 mod 4, which is equal to what? 4 comma 0. So I got an answer as 0. So this 4 is my answer. So what is my answer? Output 4. Fine. This is my approach. Let us see the code. See here, n1 comma n2 is equal to 45 comma 54. While n2 is not equal to 0, it means, because 0 is equal to false condition, right? While n1 comma n2 is equal to n2 comma n1 mod n2, right? Then print n1. So I am just printing n1. 9. Fine. So this is my answer. So this is the method 2. This all about greatest common divisor. Now let us see about least common multiple, that is LCM. So how to find? First of all, what is mean by LCM? Just I go to the basic thing. What is mean by LCM? I can say LCM of two number is a number which is divisible by those two numbers. Okay. Let us take an example so that it will be more clear. Just take for example 10 and 8. Okay. First I can do divisible by 2. What is my output? 5 comma 4. Again divided by 2. 5 comma 2. Again divided by 2. It is 5 comma 1. Again divided by 5. So it is 1 comma 1. So what is my output? 2 into 2 4. 4 into 2 8. 8 into 5, it is 40. So 40 is a least number that can be divided by 8 and also by 10. It can be divided by 10 to give 0 as a remainder, and it can be divided by 8 to give 0 as a remainder. This is a least number. We cannot find a number which is less than 40 and it satisfies this condition. Okay, this is the problem statement of LCM. This is what? LCM. Okay. Now, how to approach this problem? I can say, if this is my number, I will iterate from 1 to what is the maximum possible value? 80. Beyond 80, there's no value, right? Because at 80, definitely it will divide 8 and also divides 10, right? So I will iterate from 1 to 80, and a number which divides both 10 and 8 will be my answer. So this is my approach. Just see here, n1 comma n2 is equal to 8 comma 6 for I in range of 1 comma n1 into n2 plus 1, because n minus 1. Okay. Now if I mod n1 is equal to I mod n2 is equal to 0, which means we can also write equal to 0, and this is also correct, right? If this is the case, I will break the loop, then just print the value of I, right? So let me run this. See what is the answer here? It is 24, right? And then the next method is a formula method, where we use a formula like, if I give a two number, let us assume this is n1 and this is n2. I will say LCM is equal to n1 into n2 divided by the HCF of the two numbers. I already told you what is the HCF. We can find by using the Euclidean method, or else we can find the in a normal method, right? So let us take the example, this 10 and 8, 10 and 8. So what is the product of this 10 and 8? It is 80. It is 80, right? Again, what is the highest common factor? 2. 2. Why? Because see here, 10 comma 8, 2, 5 comma 4. Beyond this we cannot divide anything, right? So 2 is my answer. So 2 is equal to 80 divided by 2 is equal to 40. We have already got 40 as my output, right? Right? So this is the another method. What? Let me highlight it. See here, LCM is equal to n1 into n2 divided by HCF of the two numbers. So see here, I have done n1 comma n2 is equal to 8 comma 6. Then I have done the product while n2, and I have used the Euclidean method, and then print product divided by n1. That's all. So this is another LCM method. Fine. So these are all about the GCD and LCM. Thank you.